You need to find a file in your file system, a word in your document, or a variable name in your code. Computers need to do many more things internally, like finding a place in memory where they can store your data, finding the address of a specific hardware device, and so on. It's interesting that not all search problems are identical. Some are harder than others. For example, long ago, there were these things called phone books. They stored people's names and phone numbers, and they were sorted by the first letter of the person's last name. Searching through a phone book isn't hard. In fact, it's incredibly quick, as you can use the binary search algorithm to do it. You open the phone book at some random position and check if the last name where you happen to be begins with the letter that is before or after the letter you're looking for. You then open at a random position about halfway through the remainder of the stack in the right direction. Repeating this will get you to the right place in about logarithmic time. So if you have n names in the phone book, and maybe n is 10,000, then you expect to find the number you're looking for in log of 10,000, which is about 4 attempts. Not bad. Searching through the phone book is quick because it has structure. The names are sorted, and we can exploit that if we want to be quick. But not all problems are that easy. When we say we're trying to find a needle in a haystack, what we really mean is that we are dealing with something that has no structure at all. The time needed to solve this type of problem is linear in the size of the haystack. The best thing we can do is to simply check each item in the collection and see if that's the one we're looking for. How could it be any quicker? The Grover algorithm is an example of how extending the model of computation by allowing the information to be quantum allows for an algorithm that has a chance for being faster than any classical option. Instead of a runtime proportional to the number of items in the collection, the Grover runtime is proportional to the square root of that number. We call this a quadratic speedup. There are tons of resources, including in our very own Classiq documentation, where the principle of operation of the Grover algorithm is explained in depth.